So I'm fairly seriously thinking of satirically writing a calculator program that works in metric, right? So it'll throw an error whenever you try to divide by anything that's not composed of powers of 2 and 5, right? So, like half of a meter, that's fine. We can do that. That's 500 millimeters or 50 centimeters, right? That's fine. We can do that. That's because 2 is a power of 2. So we can handle that, right? But say you want to do something like a 1/7 of 3 meters. Error. 1/17 of 2 kilometers. Error. 1/25 of 2 kilometers. 80 meters, that one works. Because 25 is a power of 5. Haha. But what about 1/9 of 9 centimeters? Error. Because 9, it doesn't play fair with base 10. So we'll just get rid of it. We'll just get rid of it, right? Because base 10 is the best thing ever. Right? That's what makes metric so good, because it uses base 10. Base 10 is absolutely superior. So anything that just doesn't get along with it, we should just throw it away. Right? So the fact that 1/9 of 9 centimeters would just be 1 centimeter, well, we're not even going to think about it, because 9 doesn't play well with base 10. So we'll just throw it away. Division by 9 gives us non-terminating, infinitely repeating fractions. We don't want, or decimal expansions. We don't want to deal with that, so we'll just ban division by 9 and 17 and 7 and 3 and 6 and yeah, even 12. And for anyone who cooks in metric, right, it'll have a lookup table of the densities of lots of materials. So you'll be forced to tell the calculator what material you're working with, even if you're not working with a material at all. Say you just want to divide 17 by 4. This calculator, for one thing, it's not going to, well, it'll be able to do that, because you can divide by 4, because 4 is a power of 2. So 17 divided by 4, but the inverse of it, you could not do 4 divided by 17. You cannot do that with this calculator. But in order to just do this anyway, you're going to have to tell it, yeah, I'm working with concrete or something, right? And so, but what it'll do is it'll randomly switch between grams and milliliters on you. So that, and what it'll also do is it'll round the converted value to one significant figure. Because if you ever look at recipes in metric, there's only ever one, maybe 2 significant figures in there. And if there's 2, the second one is a 5. Always. Always. If you ever look at metric recipes, it's always that. It's, there's like 100 grams of this, 200 milliliters of that, 50 grams of this, 150 milliliters of that. That's it. That's how it works. There's only one significant figure, and except when there's an exception to that, the second significant figure is just a 5. So, whatever. And we're going to do this for precision, because metric is about precision, right? Metric is about precision, so that's why we're doing all of this, okay? So, now, say we're going to make some bread today, right? We're going to use bread, and we're going to make bread, and we're going to use metric, right? We're making bread using metric, but see, I don't know, going into this, how am I going to figure out how much flour I need? Do I need to weigh it with a kitchen scale, or do I need to measure its volume with a measuring cup? Nobody knows, because I haven't done the calculations yet with my calculator, and because this is how metric works, we have to appeal to some other authority and whatever random crap they say. So this is, I think I might actually write this program, because I think this is just a beautiful satire of what is wrong with the idea that metric is a good system, because, oh my god, all of the things I'm saying here are, like, yeah, it's satirical, but it's also just accurate. These are very real daily problems with using metric that nobody notices because everyone has to deal with it. And whenever it's something that everyone has to deal with, people just ignore it.